Hello students, how are you? Now let us discuss our next topic, magnetic effects of electric current, class 10 physics. First, we have to know that what are the properties of a magnet? Magnet always attracts iron. Clear? It has two poles. There are different kinds of magnets are there. For example, this is a bar magnet. In bar magnet, north pole and south pole is there. Like that, in each and every type of magnet, north pole and south pole is there. Like poles repel, as we know that unlike pole attract each other. Now we will discuss magnetic field and magnetic field lines. Magnetic field and field lines. Magnetic field and it's a field lines. Suppose we will take a bar magnet. This is a bar magnet. We can write north and south. We have to write, this is must. If we will not write, then we will deduct our mark. Okay. Always in outside we can see the field lines will be from north to south. So arrow mark we have to give in this way. Okay, clear? And inside the magnet always it is going from south to north. Is it clear? So it comes from north and goes inside south like this. So we can, clear? When the question will be like this, and look at here, the magnetic field lines never intersect with each other because it is coming from north and going to south always. So they will never intersect with each other. This is the thing. Second thing is that magnetic field lines, magnetic field strength of the magnet is higher in the poles and weak here, and here in the center it is almost 0. Is it clear? Magnetic field lines are having both magnitude as well as direction. If you are not giving direction, means you are not giving the arrow mark, then you are not getting mark. Already I told you that outside it is from north to south and inside it is south to north. This will come in your exam. Definitely one question will come from this magnetic field lines. So you have to do like this. Next one is that who has for first time who has given this who has done this experiment, that is Oester's. Oester's experiment. What is the Oester's experiment? When electric current passes through a current carrying conductor, it produces magnetic field lines. Is it clear around it? It is experienced by first time for Oersted. His name is Hans Christian Oersted. He has given this theory for the first time. This can be shown by the help of magnetic needle. When we will flow in a conductor, suppose this is a conductor, and in a conductor, suppose current passes from, this is positive and negative. Remember, this is positive side and this is negative side. Always small one is negative side and bigger one is positive side. But it is flowing through a conductor. Current is flowing through a conductor. If we will take a needle compass near it, it will deflect. Needle compass always shows us north and south direction, but it will deflect. It deflect means it will deflect towards, okay, that's it. So that means something happens here. Something happens in fact when current flows. This is the conductor. Conductor means a wire, metal wire. Most probably it is a copper wire. Copper is taken as a conductor. Copper is a good conductor. Already we have discussed in electricity chapter. So when current passes through this, then what will happen? This needle compass will deflect. Clear? And the direction of current will be reverse if positive will be this side and negative will be this side. Then what will happen? The current will flow from this direction. Clear? First time what happens? I have connected positive this side and negative this side. Now I have connected positive this side and negative this side. So it is now it becomes positive and it is negative side. So current will flow from this side. As we know that current flows from positive to negative. So now it will deflect like this. Clear? The arrow will be that side. Clear? From the above experiment, what we understood is that current and magnetism is correlated with each other. Clear? Now we will discuss what will happen when current passes in a straight conductor. Right? Suppose I will take a paper, plain paper, and this experiment is in the NCERT book. So obviously this is positive and this is negative, means current will pass from this side. Clear? When current will pass from this side, the paper, just look at here. This is Maxwell's thumb rule. Directly just you see, this is right hand thumb rule. Maxwell's right hand thumb rule will show us the what will happen here, as well as in circular loop also that will happen. I will show you in circular loop what will happen. First you take your palm like this, you take your hand like this, and you just curl your fingers like this. Then this is the current. When this is the current, this is the magnetic field around the current. Suppose this is the current, sorry, this is the conductor. When conductor will be here and positive charge, positive is going from this, current is flowing from this side, then magnetism will be around this. Clear? So you have to give the arrow marks like this. So field lines will be like this. Is it clear? When current is from this side, then field lines will be, if current will be from that side, then field line will be reverse. Clear? Is it clear now? I think it is clear. Okay. Now we will discuss that what will happen when magnetic field line through a circular loop. From this figure, we can clear that this one and circular loop. Out of these two questions, one question will must in your board exam. See, circular loop. What is circular loop? Circular loop is like this type of loop will be there. Okay, it is connected the positive terminal and negative terminal. Okay, positive terminal is this side, positive and negative. From this side, current will flow. Okay. This is a circular loop. Then what will happen? The current will flow like this. When current will flow like this, then what will happen? Magnetic field will be like this. Clear? Always you put your thumb like this. Then you will get the current this side. Magnetism will be around this. When it will go through this, then what will happen? It will look. We can see the current is flowing like this. Okay, in this direction current is flowing. When in this direction current is flowing, current is downward. Here current is upward direction, so magnetism is this side. Now current is in downward side, so magnetism will be like this. Clear? Is it clear? Look at my thumb. Clear? Now again it will. Is it clear? When it will come closer to the center, it will become a straight line. Is it clear? Now it would have been clear. Out of this one, or before what we have discussed, out of these two, one question will must 100%. But make sure that you have given error mark. Otherwise, you are not getting any mark. So one question might come here. What is the magnetic effect here? Here magnetic effect will be very less. It is 0. While it is going away from the conductor, this is conductor. While it is going away from the conductor, magnetism will be lesser. When it is going towards the conductor, magnetic field is higher. So higher will be here and lesser will be here. So when it will come here, this one and this one will intersect with each other, and here it will be 0. At center it will be 0. Clear? So now what are the factors affecting magnetic field? What are the factors affecting magnetic field? First one is factors, right? Factors, magnetic field lines. Magnetic field is directly proportional to the current passing through the conductor. Current passing through the conductor means when current is maximum, magnetism will be more. When current will be less, at that time magnetic field will be, the strength of the magnetic field will be less. Next one is magnetic field is inversely proportional. Second factor is magnetic field is inversely proportional. Inversely proportional means what? It will be less. When distance will be more, already we discussed, when distance will be more, then field will be, strength will be less. Distance from the conductor. Distance from the conductor. Clear? Already we discussed that when it will come closer to the conductor, the magnetism will be higher. When it is going away from the conductor, means at the time it is lesser. So it is inversely proportional. Inversely proportional means it is lesser. Third one is magnetic field is directly proportional. Third one, magnetic field is directly proportional to the number of turns. If the coil will be in a coil, the conductor is more. Number of coils. Okay. If the number of a coil, what is a coil? So coil means it is a conductor, copper conductor, when they are making a number of turns, like a circular or cylindrical shape, that is called a coil. Clear? So when the number of turns will be more, when number of turns in a coil will be more, at that time magnetism will be more, higher. Clear? Now we will discuss, now you understood what is a coil, now we will discuss what is solenoid. Solenoid is a must. Okay, solenoid is a sure shot question, it might come in your exam, so we go through the solenoid. Okay, magnetic field due to a solenoid. How magnetic field will be appearing in solenoid? Solenoid is the coil with many circular turns. As we discussed that when many circular turns will be there, that is a coil, that is solenoid. In insulated copper wrapped closely to the shape of a cylinder or circular shape. Is it clear? That is called a solenoid. This is called a solenoid. Okay, solenoid is there in your book, NCT book. You can go through that, you can refer that one. Okay, clear? This acts, one end acts as the north pole and another acts as a south pole. Suppose if it is north, it is south, you can make it is north and it is south, no problem. Okay, but it acts like a, when it is north and south pole, it acts like a north and south pole, it acts like a bar magnet. What is the behavior of a bar magnet? Already we discussed bar magnet. The same will be here in solenoid. That type of act. A current carrying solenoid produces similar pattern of magnetic field like bar magnet. Is it clear? That means if it is north pole, look at here, if it is a north pole and it is south pole, it will come, it's a blue color, so I'll take this one, white. It will come and the magnetic field line will come from this side and it will enter into the south pole. Same here, but you have to give error mark. Again and again I am saying you have to give error mark, otherwise you are not getting any mark. Clear? When current passes through this side, positive side, It is north side, north to south. Clear? I think solenoid is clear. Now we will discuss electromagnet. Electromagnet. What is electromagnet? Electromagnet is actually a temporary magnet. Sometimes we are using temporary magnet when electricity passes from this. We can understand electricity plus magnet, electromagnet. When electricity passes through it, it acts like a magnet, so it is called as an electromagnet. These are temporary magnet. How it can be? It is a soft iron core with a coil on around it with the, okay, when a coil wound, suppose this is soft iron and many coils will be wound over it, this will act like a electromagnet. It is used in bell, okay, electrical bells, as well as in motors, telephones, etc., etc., etc. Is it clear? It is a temporary magnet. Bar magnet is a permanent magnet, it is temporary magnet. Okay, while it is electricity will pass through it, that will act like a magnet. Now Fleming's left hand rule, right hand rule is omitted. Okay, Fleming's left hand rule is must. Fleming's left hand rule, it is a must hand rule. What is Fleming's left hand rule? Fleming's left hand rule, what you have to do is that nothing to do. You have to take your palm, left hand like this, 90 degree each. This one, they will be like in this shape. Clear? Thumb and forefinger and middle finger will be 90 degree to each other. From every side you can see it is 90 degree. Thumb is force, forefinger magnetic field, and this is current. Is it clear? The figure will be like this. Is it clear? Here it is magnetic field. What is this? Magnetic field. Clear? It is magnetic field. Here it is current. If current is downward, force will be here. The movement will be this side. Clear? So hold your finger like this, thumb, forefinger and middle finger. Middle finger is your current. When current is downward, then magnetic field will be this side eastward and force will be southward. Clear? If it is south direction. Clear? This is Fleming's left hand rule. Nothing to write, only this much you have to understand. Then definitely this will come in your exam. Okay, next one is another very easy question might come in your exam, that is AC and DC. What is AC and DC? AC means alternating current and DC means direct current. AC and DC. The question might come advantages of AC or AC versus DC. Okay, AC means what? Alternative current. Alternating current means half of the current is coming and half of the direct current means directly it is coming. That's why it is direct current. Okay, we will not go through thoroughly. We will go thoroughly in next class. But this is a revision class. That's why I will tell you what are the advantages. The advantages will come in your board exam. So, what are the advantages? AC can transfer. What are the advantages of AC over DC? AC's advantage is AC can transfer to a long distance, okay, without losing very less amount of energy. Clear? But in DC cannot be carried to a very long distance. Clear? Understood? So AC's advantage, that one is very big advantage. Then next one is our current, what we are using in our home, that is also AC current. Clear? In our household, in home, what we are using is that AC current we are using. Clear? Domestic purpose. Clear? DC current we are not using. Clear? DC current flows in one direction. This is another big disadvantage of DC. It will only flow in one direction, but AC can flow in forward direction as well as backward direction. Backward as well as forward. Next one is domestic electric circuit. This is a sure shot question. 100% this will come. Domestic electric circuit. Okay. There are three wires. You can see in a plug point, 3 points are there. Big point is there, big hole is there. In that big hole, that is, what is that? That is not, that is earthing. Another one is positive, another one is negative or neutral. So 3 wires are there. First one is live wire, that is called positive. That color is a red color wire should have been given there. Second one is neutral, that is negative. Black color wire is there. We have to use black color wire. Third one is earthing, that is neutral. Okay, neither positive nor negative charges, that is green color wire. Is it clear? Now we will see the earthing. We will see the wiring. How wiring is done in our domestic purpose. Clear? And here we are using potential difference between live wire and neutral wire is 220 volt in India. That is permissible. 220 volt in India. Clear? And next we will discuss, we will draw the diagram. This will come in your exam, that you have to do like this. Pole, from pole we are getting the current. From pole, what we are getting? It is coming from main supply. From main supply, where it will come? From main supply, it will come to our house. There a fuse will be there, main fuse. From that fuse, it will come to meter. From meter, it will go to distribution box. Distribution box. From distribution box, it will go to different appliances like fan. Okay, different appliances, fans, lights, etc. Clear? This we have to write thoroughly. Next one we have to draw. How we will draw? Same thing we have to draw, right? In a image like the box. Nothing to do. Clear? Live wire is coming. This is live. This is neutral. Clear? It will come. Okay. It will come. Next is then one earthing wire. This is red. Already I showed you. It is red. It's black and one green color. Huh? Okay. It will go through live and neutral wire go through thoroughly. Okay. It will come to the meter. Okay. It's a fuse. The meter. It will go to the different. Okay, it is positive, it is negative. Clear? To different appliances. Clear? And what is the potential difference here? 220 volt. Clear? Now This is, if you will do this much, then you are getting mark. Okay, clear? Now another thing left, that is fuse. Why fuse is used? This type of question will come in your exam. Fuse. What is fuse and why it will used? Clear? Fuse is also a conductor, but it is having low resistance. Means if high voltage will come, it will break up the circuit. Okay, two types can be there. One is short circuit. Fuse is used. Short circuit. Second one is overload. When short circuit will happen, already we have discussed that one live wire and one neutral wire will be there. Unfortunately, if they will come contact with each other, then what will happen? Automatically fuse will disconnect. Fuse will be melt and the wire of the fuse will be melt and this will be disconnected and we will save. Second one is overload. That by mistakenly more current will come near to us, come to our appliance home. Then what will happen? Our appliances might damage due to overload. At that time, what fuse will do? Fuse will just cut the circuit, break up the circuit, and it will be not damaged. Our appliances will be not damaged. Okay, clear? This is all about the uses of fuse. Fuse is used for that. Okay, clear? I hope this video will be helpful to you. And that's it for today. Thank you. Have a nice day.